Chapter 10. Okay, chapter 10 is the first section is about force diagrams. Just a diagram which illustrates all the forces on a body. Okay, so you have an object, a body, which has a weight being pulled by a force on a rough horizontal plane. Okay, so you can think of the body as lying on a table if you want. So you can think of it as a table, rough horizontal plane. Okay, you have a block. So block, that's my block on the rough horizontal plane. Okay, the weight of the block is W. So the weight will act downwards. Okay, so all these forces are in newtons. So you've got W, newtons acting downwards. Okay, you have been pulled to the right by a force P. So you have a pulling force P. There it is, P newtons across a rough horizontal plane. Okay, if the plane is rough, that means there must be some friction reacting on the block. So the friction will oppose the motion. So we can indicate F, frictional force. Okay, so F is a friction from the plane acting on the body. Okay, and the last force is something you may not have come across before. Okay, if the body is sitting on the plane, okay, this body does not fall through the plane. So that means the plane must be exerting a force on the body. So this rough horizontal plane, the plane exerts a force on the block. Okay, and that force acts upwards. Okay, and that force is called the normal reaction. So it's called the normal reaction. So if you do physics, you may have heard of this before. Normal reaction. Okay, so they use the letter R usually. So the normal reaction is the force which the plane exerts on the body. Okay, so that force basically it prevents the body from falling through the table. So those are the four forces acting on the body. Any questions? So the next bit, when forces act upon an object of balance. Okay, this word equilibrium. So equilibrium just means the forces are in balance. So basically it means like the upward forces equal the downward forces, right equals left. So equilibrium means something like, you'll see later, upward forces are equal to the downward forces. And also the forces acting, the left forces equal the right forces. So the left equals right. So all the forces are in balance. So essentially that is what it means. Acting upon a body, forces are balanced. So this is what equilibrium means. Okay. Okay, then we have Newton's first law of motion. So again, you must have done this in physics. Newton's first law says that an object at rest, so if an object is stationary, it will stay at rest. And that's an object moving with constant velocity will continue to move with constant velocity unless an unbalanced force acts on the object. So this means that an object will stay stationary, so the object will not move, or an object will continue to move at a constant velocity unless it's acted on by a force. Okay? In other words, only a force can produce a change in velocity. That's what it basically means. So in other words, you need a force to produce a change in velocity. If there's no force, then the object will continue to move at a constant velocity, or it will just remain stationary. So you need a force to produce a change in velocity. So whenever there's a force, there will be an acceleration. So in other words, you need a force to produce an acceleration, i.e., again, you need a force to produce an acceleration, to make a body accelerate, to make a body accelerate. And that's what Newton's first law is saying. A resultant force acting on the body will cause the object to accelerate. Okay, so this resultant force is just the sum of all the forces, basically. A resultant force acting on the body. So this word resultant force means it's the overall force, the sum of all forces. Okay. There's one example. You have a body, you've got a particle, and there are 4 forces acting on it. Draw a force diagram to represent the resultant force. Okay, so you need to think about what the overall effect is. So you've got 20 newtons acting to the left, you've got 20 newtons acting to the right. Okay, so there is no resultant force, there's no horizontal force. Okay, got 30 newtons acting upwards, and you've got 10 newtons acting downwards. 30 take away 10 is 20. So the resultant force must be 20 newtons upwards. So when they say resultant force, they want to see a diagram like this. So the left equals right, so there's nothing to consider. 30 take away 10 is 20. So 20 newtons upwards. This is the resultant force. So it's the combined effect of all the forces taken into consideration. So Newton's first law says that if you have a force acting on a body, then the body will accelerate, but it will also accelerate in the same direction as the resultant force. So the body will accelerate upwards. So describe the motion of the particle. The particle accelerates upwards. The particle accelerates. So it accelerates because there's a force. There is a resultant force acting on the body. So the particle accelerates, and the direction of the acceleration is the same direction as the resultant force. So the particle accelerates upwards as well. The next section is called forces as vectors. So it's nothing new. Okay, so you can write a force as a vector using this IJ notation again. So if you've got a force, say F equal to say I plus 2J, the units are in newtons, so you put N for newtons. So that's a force vector. So that tells you 2 things. It gives you the direction of the force, and you can also get the magnitude by doing Pythagoras. So the first thing you can notice is that the magnitude of the force is 1 squared plus 2 squared is root 5 newtons. Okay, the direction of the force, so it's moving 1 to the right, so it's like 2 up. Okay, so that's the direction of the force F. So it's a 1 to the right and 2 up. So that's what a force vector does. It gives you the direction of the force, and you can also do Pythagoras to get the actual magnitude. Okay, so you see that idea before. Okay, you can find the resultant of 2 or more forces as vectors by adding the vectors. Okay, so you do the obvious thing. So if you've got multiple forces, F1 as a vector, you've got F2. Okay, suppose you've got like 2 forces acting on a body. So you've got a body, some particle there, and you've got some force acting on it, F1 and F2. acting on a particle. Okay, so suppose you've got two forces, then you can work out the resultant force by simply adding the two vectors together. So to work out the resultant force, the overall effect, the resultant force, you just add up the forces together. So it doesn't matter how many forces are acting on the particle. To get the resultant force, you just add them together. So you use F1 plus F2. That's all you would have to do. Okay, so example 3. So you've got three forces, you've got four forces, 2i, 3j, 4i minus j, minus 3i plus 2j, ai plus bj, act on an object. So you've got four forces acting on an object, which is in equilibrium. Okay, so equilibrium means everything is balanced. So it means the sum of all the forces is 0. That's what it means in terms of vectors. So it's telling you that the resultant force is exactly 0. So you think of it as 0i plus 0j. And that's what the statement is saying. The forces are in equilibrium. So you can make an equation and find out the value of A and B. So I'm going to use column vectors. Okay, so 2i, 3j. Plus A and B is precisely equal to 0, 0. Together, 4, 5, 6. 6 take away 3 is 3. 3 take away 1 is 2. 2 plus 2 is 4. So that tells you, hopefully, A is minus 3, B is minus 4. So you can tell by looking that A is minus 3 and B is minus 3. Next one. Okay, so in the question, they always say I is due east, but we already know this. I vector due east is always to the right. J represents the unit vector due north, so it's just upwards. So we know that already. Upwards. Okay, a particle begins at rest at the origin. It is acted on by three forces. 2i. Okay, so you've got three forces acting on a particle. Find the resultant force. To find the resultant force, you just add them together. So for part A, we'll look at the resultant force. Okay, so I'm going to use column vectors. You just need to do 2, 1 plus 3 minus 2 plus minus 1, 4. I'm using column vector notation. 5 take away 1 is 4. 5 take away 2 is 3. They want the answer in the form PIQJ. So the answer you would write then, resultant force is 4i plus 3j. So that's the resultant force acting on the particle. Part B, magnitude is just Pythagoras. They want the magnitude and bearing of the resultant force. Okay, so we call that R for short. So we call that. Okay, so they want the magnitude of R. So you just do Pythagoras to get the magnitude. So it's 4 squared plus 3 squared, which conveniently root 25 is 5 newtons. The bearing of the resultant force, so they want to think about the direction. So the direction is 4 to the right and 3 up. So you think of it as 4 to the right, 3 up. So it's 4 to the right, and 3 up. So the bearings are always measured clockwise from the north line. So the angle they want, it's not just any old angle. Bearings are measured clockwise from the north. So the bearing, so you draw the north line. They need to describe the direction as a bearing. So they want this angle clockwise from the north. Okay, so you need to calculate that angle. Okay, so it's going to be, so if I call that angle theta, so that angle you would do 90 take away this angle, inverse tan 3/4. Okay, normally bearings are given to you as 3 digits. So they like to see 053.1 degrees. Okay, so that's the bearing. And the last part, describe the motion of the particle. So because there is a resultant force, that means the particle is going to accelerate, and the direction of the acceleration will be the same as the vector y plus 3j. Okay, so part C, you could say the particle accelerates. So because there's a resultant force, it has to accelerate. Particle accelerates in the direction of the resultant force. So in other words, in the direction 4i plus 3j. So it's accelerating. So basically, so the acceleration is in this direction. So the particle is accelerating in that direction. Okay. Any questions?